We had a few more organic molecules to draw and to name, or just to draw and give structures, I guess. We have the names. First one is 1-bromo, 2-fluoro, octane. There it is, 8 carbons with a fluorine on the number 2 and a bromine on the number 1. And my 8 carbons. You can choose this as 1 or this as 1. Let's put it here. Bromine and fluorine. And then the rest is H. And then in terms of a condensed structural, you'd want to be writing this large structure a little more concisely. And so we would write it CH2Br, and then we have a CHF, and then we have a CH2 repeated 1, 2, 3, 4, 5 times before a terminal methyl group. Yes, you can put this bromine in brackets and that fluorine in brackets if you like, but really we know that the halogen is not within the backbone, so that we don't have C bonded to Br bonded to C bonded to F and so on. So again, some flexibility. And in terms of a line angle drawing for this compound that has 8 carbons, so here's my first carbon, and then I move to 1, 2, 3. The second, that was 1, 2, 3, 4, 5, 6, 7, and 8. Again, carbon number 1, 2, 3, 4, 5, 6, 7, 8. And on carbon number 1, I have a bromine. So this does not mean that it's going to another C. It means that this C is bonded to that bromine. And on carbon number 2, I'm going to go up now to a fluorine. And that one is done. The next one I have is 3-heptene. Just move this up. 3-heptene. I know that this is an alkene. It's a hydrocarbon with a double bond. And the HEPT tells me that it is a 7. And this tells me that there's a double bond between carbon 3 and carbon 4. So I labeled the double bond using the smaller of the 2 carbon atoms, the smaller of the 2 numbers. Okay, so 7, let's put it here. 1, 2, 3, 4, 5, 6, 7. And back on carbon 3 and 4, there is a double bond. That's all there is to this molecule, except for its hydrogens. And don't go too fast here and put 2 hydrogens, because carbon only makes 4 bonds in total. So there's 1, 2, 3, 4. That's it. And just for some variety, I'll put the other proton or hydrogen down here. This is a CH2. So is this one. And then we have another terminal methyl group on the compound. In a condensed structural, I would write CH3, CH2, CH, and then CH2, CH2, CH3. And we can be even more condensed than that, because when we have repeating things, we can put them in brackets, but we'll just leave it like that. And the line angle for 3-heptene, let's just put it so that's the only one we're looking at. The line angle for 3-heptene, again, 7 carbons, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, so between 3 and 4, a double bond. That is your 3-heptene. And the next one we had was 3-hexanol. So this class or type of compound is an alcohol. It is 6 carbons long, and the hydroxyl group is on carbon number 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. OH, and then saturate. Condensed. One, 2, 3, 4, 5, 6. I'm sure you didn't add any extra carbons when you draw it. And a line angle. Line angle for 3-hexanol. 1, 2, 3, 4, 5, 6. And then on carbon 1, 2, 3. An OH group. That's that. And the last one that we had on our list was 2-methyl-3-decanol. I think we can squeeze it in at the bottom here. What did I say it was? 2-methyl-3-decanol. It is an alcohol, 10 carbons long. The hydroxyl group is on carbon number 3, and there's a methyl substituent, which is CH3, hanging off of carbon number 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Almost off the paper here, out of view. 1, 2, 3 is my OH, and on number 2 I have another methyl. And then we'll add what we need. Go right around and back. Condensed structural. CH3, CH. Now make sure that when your pendant group is a methyl, because that could be part of the backbone, that you put it in brackets to make sure I know that that guy is attached to this one. So there's my CH3. Then I have a CHOH. And then I have 1, 2, 3, 4, 5, 6 CH2s, and then a CH3. So that's just for the sake of repeating, but these brackets we recognize them being there to indicate that those groups are functional groups as pendants on those carbons behind. And our last line angle drawing is going to have 10 carbons in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, on carbon number 2, I have a methyl, so I'll put that one up. On carbon number 3, I have an OH, and I'll point it down. And that's it. Those are all our examples.